Hi, hello all. I am Soumya. I am working as an assistant professor in SNS College of Technology, Coimbatore. Today, we are going to discuss an important concept in data visualization, that is optimal quantitative scales. When we represent the numerical data visually, the choice of scale plays a huge role in how the audience interprets the information. If we choose the wrong scale means it can mislead the viewers. So let's understand what a quantitative scale is and how to make it optimal. First, let's we see what is a quantitative scale. A quantitative scale is a way to map the numerical data to a visible variable such as length, position, size or color intensity. For example, in a bar chart, the height of bars represents the values. In a scatter plot, the position on axis shows the numerical values. The main purpose of a quantitative scale is to help the viewers interpret how much or how many by comparing the visual marks. Without an appropriate scale, the data could be misinterpreted. Next, why do we need an optimal quantitative scale? Why is an optimal scale important means a poor scale choice can mislead or confuse the viewers. A good scale ensures the message is clear and accurate and honest. So, our goal is to apply the best practices that make the data easier to understand while avoiding the distortion. Key principles of optimal quantitative scale. The first principle, start the axis at 0 whenever appropriate. Especially for bar charts, a 0 baseline is critical because the length of the bar shows the magnitude. If we start at 50 instead of 0, small differences look exaggerated. Always use 0 baseline for bar and column charts. For line chart, we can sometimes avoid 0 if we are focusing on small trends, but we must label it clearly to avoid the confusion. Next, the second principle is use consistent intervals and units. Scales must be evenly spaced so they don't distort the data. Also use the meaningful units like a rupee symbol, percentage symbol or kg. And the third principle is avoid over precision. Showing the values like 62.3489 kg doesn't help. Instead, rounding to 62.3 or 62 makes the chart cleaner and easier to read. Then, fourth principle is choosing an appropriate range. If the range is too wide, patterns look flat and hard to interpret. If the range is too narrow, small differences look exaggerated. For example of a score's range from 78 to 92, using a y-axis from 0 to 100 hides the variation. Instead, use 75 to 95 for better clarity, except for bar charts which need zero baseline. Then, fifth principle is label clearly and accurately. Labels should be easy to understand and not too overcrowded. Matching the data using logical tick intervals like 0, 10, 20 instead of odd values like 7.3, 14.6. Good labeling helps your audience read the visualization quickly. Next, principle number 6 is use logarithmic scales when necessary. Sometimes data spans multiple orders of magnitude like a pollution sizes from 10 to 10 million. Your normal scale can't handle that well. In such cases, use a logarithmic scale but always indicate that it's a log scale to avoid the confusion because it changes how distances are perceived. Next principle is align the scale with the audience understanding. For example, say 10,000 people instead of 1E4. Use units and formats familiar to your audience. This ensures clarity and avoids the unnecessary mental conversion. And to summarize the principles for an optimal quantitative scales are Start the axis at 0 when appropriate. Then use consistent intervals and units and avoid over precision and choosing an appropriate range and label clearly and accurately. Then use logarithmic scales when necessary. Align scales with audience understanding. By following these guidelines, your visualization will be clear, accurate, and trustworthy. Thank you for watching.